Geometric relationships. What angle relationships are formed by a transversal? That's what we're going to answer in this little quick video. So first we have parallel lines, and parallel lines are lines that never intersect. They have the exact same slope. So we're going to keep that definition and work with it. And what we're going to do is we are going to draw another line across those lines, and we're going to call that line a transversal. And the word transverse means to cut across. And a transversal is a line that intersects a set of lines. And what will happen when a transversal crosses two parallel lines is we will have angles, and those angles, 8 of them, will be created, and there are special relationships that those angles have. And what we're going to do is go through those angles. So first off, we're going to have what we call corresponding angles. And corresponding angles are angles that are congruent to each other. I'll write that word here, congruent. Congruent, the word congruent means equals. So what we're going to do is take things that match up. So we know that angle 1 is corresponding to angle 5 because they're on the same side of the transversal and on the same side of the parallel lines. You can see in angle 1 and 5, they're above the parallel lines and on the same side of the transversal. We can say the same is true for angles 2 and 6, as are angles 7 and 3, and also angles 4 and 8. So we have 4 sets of corresponding angles, and all of these angles are congruent. Now let's talk about vertical angles. Now vertical angles are angles that are opposite of each other. Now here we have angles 1 and 3. They are opposite of one another. And angles 2 and angle 4 are opposite of each other. Angles 6 and 8 are opposite of each other. And angles 5 and 7 as well are opposite of each other. We know that vertical angles are also congruent. So it's important to know which ones are congruent and which ones are not. Speaking of not, here we go. Here we have some adjacent angles. Now adjacent angles, we're going to get a ton of them. Why are we going to get a ton of them? Because they're angles that are side by side. So let's take a look at this. Angles 1 and 2 are side by side. Angles 4 and 3 are side by side. Angles 5 and 6 are side by side. Let's get some more colors in here. Angles 8 and 7 are side by side. We're going to have some more too here. We're going to go in the other direction. How about angles 1 and 4? They're adjacent to each other, as are angles 2 and 3. As are angles 5 and 8. I have a hard time choosing colors. As are angles 6 and 7. So in this case, we can see that instead of the 4 pairs, we've got 8 pairs. So we've got so many pairs to choose from. So what that's going to tell us is that these adjacent angles, they are not congruent, are they? They form 180 degrees. These are what we call supplementary angles, and I'm going to talk a little bit more about that in a moment. Okay, let's take a look at alternate interior angles. Alternate interior angles are angles that lie on opposite sides of the transversal and are non-adjacent between the parallel lines. So let's kind of break that apart a little bit. Okay, alternate interior angles. I want to focus on the word interior. Interior means between the parallel lines. So when we're looking at the parallel lines, we notice there are 4 angles between the parallel lines, 3, 4, 5, and 6. So using that, we're going to find our matching pairs. So here we have 4 on one side. So since it's alternate, it's going to be on the other side, which would be 6. Now there's going to be another pair. It would be numbers 3 and 5. So here we only have 2 sets that are alternate interior angles, and these as well are also congruent. Oops, let me get an eraser. Congruent. And remember, the word congruent means that they're equal and they have equal measure. Now we have alternate exterior angles. And alternate exterior angles are angles that lie on opposite sides of the transversal outside of the parallel lines. And this time we're going to be outside. That's what exterior means. So when we look at the outside of the parallel lines, we have numbers 1, 2, 7, and 8. And what we want to do is just put together the ones that are alternating. So angle 1 is going to alternate with angle 7 on the opposite side of the transversal. The same is true for angle 2 and angle 8. They're on the opposite side of the transversal. So these are also congruent or equal measure angles. Now let's get back to that concept of supplementary I was talking about a moment ago. Supplementary angles are angles that add up to 180 degrees. In other words, they would be added together to make a straight line. Here we have that straight line cutting across. So that means if I added these two angles together, angles 1 and 2, I know together they would equal 180 degrees. Now, how does that help me when finding things? Well, it helps me to decide what's going on. For example, if I know that angle 2 measured 120 degrees, by definition, that would tell me that angle 1 measured 60 degrees, because 60 degrees plus 120 gives me 180. Complementary angles are similar to this as well, except that complementary angles add up to 90 degrees. And we can see that little 90-degree angle in there. So if I added them together, I would get 90 degrees. Again, let's say, for example, that angle 1 measured 65 degrees. Excuse me, where am I writing there? 65 degrees. That means angle 2 would measure 25 degrees, because together they would be 90 degrees. Okay. Let's try to put something together now. Let's take all this information and see if we can prove something. Okay? So here, how many degrees is this line? Hopefully you realize, and we've just been talking about, that all lines measure 180 degrees. So let's keep that in mind while we're working. And let's draw a second line and make parallel lines. We're going to make some parallel lines, and then what I want to do is add a transversal to it. We're going to cut it by this transversal, and we're going to put this number 1 here next to it. So which angle has a corresponding relationship to angle 1? Well, it's right here. This one right here has a corresponding relationship. So here is our angle 1 that they are in common. If we draw another transversal cutting across the other direction but meeting up at the top of that parallel line there, and I'll put angle 3 right there, and I'm going to ask which angle has a corresponding relationship to angle 3, which is right here in the middle. There it is. And we can see that corresponding relationship on the same side of the parallel line, on the same side of the transversal. Now if we take a look here at angle 2, which is right above here, I put it in that empty space, we want to know which angle has a vertical relationship with angle 2. Well, since angle 2 is right here, the vertical relationship is right underneath it. So let's see if we can kind of pull some things together based on what you see. Hopefully you're having an aha moment just like I am. You're noticing something.
Yeah, baby, yeah.
Yes, what figure do you see in the middle? You see that there is a triangle. So let's take it a step further. Let's take a look at the top above that parallel line that we had the angles 1, 2, and 3. And I'd like to know, what do angles 1, 2, and 3 add up to? Well, we remember that a straight line adds up to 180 degrees. Well, if that's true, the interior of the angles must mean that all angles in a triangle always add up to 180 degrees. So we want to keep that in mind, and this is a proof for the angles of a triangle. This is why all angles in a triangle do add up to 180 degrees. So hopefully this explains a little bit about geometric relationships.